And first of all, let me share with you what I intend to do in the next few minutes, because the first session was about scientific information, innovation, social responsibility, but you could see in the presentation before the coffee break that essentially what all the lecturers did was to explore the connection between these various concepts. It's not one leading to the other, but exploring and giving thoughts on the interconnection. So what I will do, although it's on technology, I will still keep the same thing and add, from my perspective, these things. So the slides, some of you might have seen some of the slides, but the way I will use them will be different. I just want to share with you some thoughts, some of the problems we have been facing, maybe some of the way we've been solving these problems. Some are not solved, by the way, but certainly I don't want to be presumptuous and to give you clues on how to do it. It's a complex issue, so I just want to sort of share a few things with you. So when it comes to meteorology, actually, something which is very interesting is that going back to the 17th century, the invention of the instruments, and certainly it increased in the 18th century. It was felt by the scientists dealing with this weather observation that they had a social responsibility already at the time. They felt that if they could do it, it was very important not only to make these observations in a standard way, in something which was, but also to share them with all their colleagues across. It was mostly, the original networks were mostly in Europe, so it was sharing them freely already in Europe, but going one step further, how to translate that information, that observation into knowledge, which can be used for social activities. And at that time, as you know, there was very much talented people. I just put on purpose this quote by John Ruskin, and you may know him as either an art especially critic, or you may know him as a poet, or you may know him in different capacity. It's the same one. It's the same one. But people were linking these various fields in a very sophisticated way. Actually, last week I was discussing with Professor Schopper about Goethe. And for me, Goethe, his main quality, besides being an outstanding poet, is one of the first person who designed a classification of clouds. So it was very interesting to see that this feeling about social responsibility and going beyond your own strict silo, but going further. The other thing I want to say on this slide and the other slide is that to work, to be successful, cooperation is an essential element. Already in the middle of the 19th century, when it was called the IMO, the International Meteorological Organization, was created, it's more than 140 years ago. The reason for creating it is that it was realized that no country can do it alone. Everyone has to work together. All scientists of the planet have to work together and exchange their thing for the benefit of all. And at that time, the main application was safety of travel over the oceans. That was the main application. You have seen, interestingly enough, comments recently about 2 cyclones hitting Yemen and the Arabic Peninsula. And people often tend to say, we have never seen that, by the way. This is from 1885, a tropical cyclone hitting the Gulf of Aden at the time. It was one of the first maps. And it was not, the difference is that it was observed, it was not predicted. Now we can go one step further because of the scientific progress. The scientific progress could be translated into early warnings, and therefore a lot of action. You cannot prevent the cyclone from occurring, but you can certainly minimize or even prevent the fact that it turns into an absolute disaster for many of these extreme events. So to do that, again, we need cooperation. We need people to get out of their boxes. The reason why I put this man with a cap behind is because the oldest international organization is the ITU. It's not us, it's the ITU. Why? And the ITU needed to be created before WMO for a very good reason. Because we needed the invention of the telegraph. The telegraph allowed us to exchange in real time all this observation across the planet. So there's a very good reason why we had to wait for this to be put in place so that we could put all that together. But again, responsibility. What do you do if you have a conflict? If you have some things, do you still exchange observation? Do you keep them for yourself because they can have a strategic value? Now, the beauty. And that may be unique, although I'm talking under the control of my friends from WHO, maybe they will contradict me. Where it may be unique is the fact that if we were to stop exchange of observation, every country would be a loser. Every country, including USA, including European countries, including China, gets more out of this exchange than what they put into the exchange. So therefore, we are very fortunate. I don't have to justify with my member states the benefit of cooperation. They take it for granted. I don't have to justify that. I'm very fortunate. I'm incredibly lucky because I know many of you have to justify what is the benefit. I don't have to do that. But what I have to do is to show the benefit in terms of social, not only in terms of improving the quality of the prediction, but what does it mean in terms of life saving, in terms of economic impact, and so on. So, to do that, one of the key is to make sure that people don't do this, for example, this is for the observation in their corner, in an uncoordinated way, but that everything is coordinated. And we are very strange people in the scientific community because we make use of almost anything which is available, provided we have enough information on the type of observation, on the way it was done, on the metadata, and so on. But we can make use of the most incredible or the most unusual things. You have here the sort of traditional observation, and you are familiar with many of them: satellites, airplanes, radars, the normal temperature buoys, and we have buoys going, you know, like the toys of the children in the ocean, going floating, sending information to satellites, then diving down, drifting, then going back to the surface to send back the information they got. We use all that. But sometimes we have very interesting information coming from unexpected corners. For example, this little instrument that most of you have is sometimes for us a nonsense. I can tell you why. Because it's so popular that we had to, every 3-4 years, we have to struggle within the ITU so that the telephone operators don't steal the frequency bands that we use for observing the atmosphere, because the molecule react to certain frequency, which unfortunately are also very useful for that. And if these frequencies are used for that, they cannot be used for observing the atmosphere. So far we have always won the battle, but it's an incredibly difficult and challenging battle. But some of the things like the GPS, when you get the GPS signal going from one satellite to the other, it's perturbed by humidity. Well, not good news for telecom people. Excellent news for us. We take that perturbation, we invert the perturbation, and we translate it into incredibly accurate information on the humidity profile along the trajectory. So this is just one example of things that we use. But the challenge afterwards is to put all these things together to create a state of the atmosphere. Satellite, you may think, and of course, I know I'm talking to a very highly educated scientific audience here, but I'm sure you know that satellites don't measure temperature, they don't measure humidity, they don't measure wind. They measure some strange thing, radiancy, and that has to be translated back into something useful for the numerical, the mathematical model. And it took us more than 20-30 years of quite heavy research to come to the situation we have now, where we can make good use of that. It took a very long time. Now, back to the responsibility. I'm using on the top left the current constellation of satellites, which provide us on a daily, on an hourly, on a few minutes basis with information which is used for making early warning prediction, but also for analyzing the state of the climate. You see, it's about 25, 30 satellites. They are operated by different countries, a group of countries, of course the traditional one, USA, Europe, Russia, but also now China is really part of the big players there, Japan, India, and so on. So it has to be coordinated so that, for example, they are big equipment. We're talking tens of billions of dollars per year for that. So it is a significant investment, and we have to make sure that if, for example, one of these satellites defaults, there are sort of backups, and this backup can be operated by different countries. So how do we make sure that countries are willing to share this information? Because some of it is for pure civilian use, but some of it could have some military application. So it has been a challenge for us, but we have managed, and we have got an agreement that all the countries operating these satellites agree under the WMO space program, and they coordinate the action, and they act as a backup to each other. And all the information from all these satellites are exchanged freely across all countries of the planet, irrespective of the political tension. And that was also the case during the Cold War. So the other graphic I want to spend a little bit of time on. Where is, yeah, the pointer. The top right graphic. This is illustrating the evolution of the quality of the weather forecast since 1980. So the higher the curve, the better the quality. The top line is almost perfection. It's 100% what we call anomaly correlation. It's correlation between the deviation from the sort of standard state. It's just a standard measure which is extremely informative on a global scale. The top line, blue curve, is correspond to, I think, let me say, it's 3 days, forecast 3 days in advance, the red one 5 days in advance, the green one 7 days in advance. So you see that now the quality of the forecast 5 days in advance is better than it was 3 days in advance 30 years ago. Actually, we consider we have gained more than 1 day of quality every 7 years. So over the last 20 years, we have gained about 3 days of quality, which is significant. But there are many other messages on that. One of the messages, you see the blue, it's not one curve, it's 2 curves. The top one is the quality in the northern hemisphere, the bottom one is quality in the southern hemisphere. So you see the quality is now the same in both hemispheres, while there was a significant difference 30 years ago. Reason, satellite data. Because before, the quality of the observation network was much less in the southern hemisphere. The other message on that is that this is great. We're very happy to have very good quality of that. But again, social responsibility. How do we translate? This is scientific satisfaction for me. But how does that translate into something useful for decision makers? How do we translate that into early warning, into products which can not only save lives, which can contribute to the economy, which can contribute to the sustainable development agenda? So the problem to do that, and I will come to it in a little bit more, I will spend a little bit more time later, is the fact that we need to have cooperation across disciplines which do not have always the experience of working together. But let me, I don't want to spend too much time on that one. Just for you to illustrate one of these cross-cutting things, the bottom right corresponds to, I'm sure you recognize, it's the famous butterfly effect, it's the chaos things, and these are graphics by Ed Lawrence. He was, as you know, or as you may know, he was a meteorologist, and actually he based this data on a very simplified meteorological model. Actually, he did that when he was in Europe, and it happens that I was working with him. I provided him with some of these data to do his research. But it was one of these examples of cutting across disciplines. The other thing is, not only the scientists are making use of scientific development, but often they do influence scientific development. I'm sure you have that in CERN. In our discipline, many of the satellite development were triggered by requests from meteorologists. After the launch of the Sputnik in 1960, one of the very first satellites providing regular information was a weather satellite in 1960. Just before coffee break, it was mentioned the development of supercomputers. The very first electronic computer, the ENIAC, in the team of John Neumann, there was a scientist from Sweden called Rosby. And the very first application on the ENIAC computer was actually weather forecast. So that's just to show, and many of the things which were developed were done not only for these models to make use of what was available, but to influence the development of the computers. And that was in particular the case with Cray research. And in the place where I was before, a place in England, we had for more than 20 years constant interaction with Cray research on the development of their computers. So many of the architecture development were made to support this particular application. So that was, sometimes it's not always realized. But it shows that the relationship, the responsibility go beyond the pure sort of customer to provider relationship, but there's a synergy which is hopefully useful beyond the strict discipline that we are working in. Climate. Some of you might have noted 2 days ago, we released the latest information on greenhouse gas concentration. And the news are not good news. You see these curves correspond to the evolution over the last 30 years for the 3 main greenhouse gases, CO2, methane, and nitrous oxide. All of them are going up. For all of them, we have broken new records this year. And when I say new records, we can also say that these are record level for more than 800,000 years. Because of the way we analyze the composition of the air bubble in ice cores over Antarctica, which allow us to go back 800,000 years. So these are really worrying news. We are now in uncharted territory, which humanity has not known for probably more than 1 million years, and most likely for even much, much longer. So this is not good news. And the other bad news is that we have, because some of these gases, in particular CO2, which represent more than 60 to 65% of the warming potential of these greenhouse gases, CO2 stays in the atmosphere for hundreds of years. So whatever we put there stays there. So it's cumulative effect. So if we don't take action quickly, it will be very soon impossible to stay under the 2 degrees. This is the whole challenge about the Paris conference. We have exhausted a significant part of our carbon budget. So now, very quickly, sometimes you hear about climate. There's been a pause in the global warming, and my answer is which pause? Sorry. These are the facts. These are the facts, and if you from year to year, sure enough, you have a big variability from year to year, and that's why we recommend that you should look at the trends over a longer period, because over a short period you might have interaction between ocean currents, between atmosphere, between many things. So we look at the trends over a longer period, and you see for each decade, the bottom graph since the 1880, and you certainly see that recently we have broken decade after decade. We have broken new records. Every decade has been warmer than the previous one. So the pause, which pause? And the pause comes from something which is not science. And people say when they say there's been a pause, they start their graphic in 1997, 98, where there was the strongest El Nino of the previous century. During El Nino, the temperature tended to be warmer. So if you start your graph at a particular point, which happened to be an exceptional point, and you finish at another particular point, which happened to be a cold point, you don't get the right signal. This is not, I'm afraid, this is not what I call science. This is what I call manipulation of data. So These are the facts. And on the top left, if you want to look with even longer averaging period, it's 30 years. This is what we, WMO, recommend actually for climate studies to average over 30-year periods. This is what you get. Since 1880 again, every 30-year period has been warmer than the previous one, but you see it's accelerating for a good reason, because concentration of greenhouse gases are higher. These are the facts. This is the reality. So, 2030 Sustainable Development Agenda. What do we do? Climate, there's a goal on climate. It's goal 13, I believe, from... climate is there, but climate is almost in every other goal. Something which is quite different nowadays is that if you look at each of these 17 Sustainable Development Goals, all of them are cross-cutting. There's not a single exception. All of them require cooperation across disciplines. All of them require people to work together, and sometimes they don't have the culture, or even less the experience to work together. So one of the key issues is how do we make sure that technology and scientific development are properly integrated, are properly used in that. So definitely we need to strengthen cooperation. We need to strengthen the sharing of information. We still have too many disciplines where the scientists, even our community, we have to accept sometimes, is not willing to share the information for a number of reasons. I'm lucky, I'm coming from a community, meteorological community, where this tradition is really in our genes, and it has been there for more than 150 years. As we speak, North and South Korea exchange their weather observation in real time. Palestine and Israel, even before the warming up, USA and Cuba for hurricane. It works, no restriction. But it's not the case in other things, including for hydrology, which is another discipline close to my heart. So I'm talking too much already. So what I want to say here on this graphic, cooperation. You see, what we are developing is we are developing some special tool. When I say we, it's all at the intergovernmental level. It's all our colleagues from the United Nations systems to develop services which can help decision-making in the field of climate. And we have identified what we call climate services, 5 initial top priorities: climate and health, food security, disaster reduction, water management, and also we have added energy recently. But for all of them, we need very, very close cooperation. Example, with WHO, we have set up a joint unit in Geneva just to deal with that jointly. And we realized that by putting the two together, the added value was just enormous. It was much more than the cost of doing it. Cooperation is a cost, but it is also a big added value. So I just want to insist on that, and let me finish on that one, because I think it's also very close to this thing. We have to take into account a number of ethical principles, and I know you've been thinking a lot in CERN about that. We have a lot to learn from you, and in the climate area, it is much less developed, but we have to take that into account. But something we know for sure is that today, we know enough so that in the future, our responsibility towards future generation is enormous, because we shall not be able to say we didn't know. Sorry, we know. We know enough to take action, and if we don't take action, our children, our grandchildren can sue us. So let me stop here. Thank you very much. Merci beaucoup.